There is a fundamental evolutionary patterning in which, with each new era and phase of technology and social economic venturing, both the tools and their products get bigger and bigger, and the numbers of humans involved multiplies. A period of doing more with more until a mammoth peak magnitude is attained, which is followed by evolutionary production of ever more effective results with ever less pounds of material, ergs of energy, and seconds of time, all of which integrating synergy produces ever more comprehensively effective tools with ever smaller technological artifacts produced by ever fewer unskilled human workers. The 1895 to 1929 Model T waxing to the 1960s Cadillac limo, then waning to the 1980 Japanese Honda. For example, trans-ocean traffic brought into use ever more gargantuan ocean liners, leading eventually to the 5-day Atlantic crossing leviathans such as the 81,000-ton Queen Mary and her sister ship, the Queen Elizabeth, using the World War II technology's new lightweight, high-strength, saltwater impervious aluminum alloys in her superstructure. The SS United States was built to carry the same number of passengers and the same amount of cargo, and to cross the Atlantic at the same speed as the Queen Mary, though weighing only 45,000 tons, that is 55% of the weight of the Queen's. These 5-day Atlantic crossing passenger carriers are now obsolete. In 1961, 3 jet airplanes outperformed the SS United States in carrying capacity in hours instead of days and at less expense. In 1980, ever lighter, swifter liner-type steamships are being built, but only for luxury cruise ships. For 20 years, these obsolete ocean liners have been progressively replaced by 10 to 30-ton, one-third of a day transatlantic crossing jet aircraft. Another example of the little to big to little evolution is manifest in the world of mathematical computing. In developing trigonometry and its solution by logarithms, thousands of monks worked for hundreds of years to produce the 1-degree tables of sines, cosines, tangents, and cotangents. During the Great Depression years of 1930 to 1936, the British and German mathematicians were hired by their governments in a joint project to calculate the table of functions to a 1 minute of arc exactitude. Then came the big post-World War II calculating machines. Univac et al. Filling whole university buildings with thousands of thermionic tubes. Then came the tubeless transistor and computers weighing and bulking far less, until we came to printed circuits and chips and tabletop equipment doing better work than the whole building filling equipment. Before all this, I myself spent 2 pre-calculator or computer years carrying out the trigonometric calculations for geodesic domes. I had to do so longhand. Then appeared 75-pound electric calculating machines, followed by the pocket-sized computers with which the trigonometric problems that took me 2 years of work became solvable in 1 day by 1 person. This process promises within a few years to become so miniaturized and so comprehensively capable as to be the size of a hearing aid, though able to interact with all the world around computers and able to discern how best to operate our planet, making obsolete the opinions of corporate or government executives.